Recent exploration of the potential uses of lignin derived from fruit pomace, which is the residual waste from fruit processing, in various biomedical applications has been undertaken. The focus on the valorization of pomace lignin is due to its abundance, renewability, and unique chemical properties. Here are some key points with details. Pomace constitutes a significant proportion of fruit waste, ranging from 25 to 50% of the total fruit mass. Notable examples include apple processing, which produces around 10 million tons of pomace annually. Fruit pomace is rich in cellulose, hemicellulose, and lignin.
For example, cherry pomace contains up to 6 to 9.4% lignin, making it a promising source of biopolymer material. Lignin-based hydrogels show promise in wound healing due to their biocompatibility, water retention capacity, and antimicrobial properties. Lignin content has been shown to enhance these properties, allowing the hydrogel to support cell growth and deliver drugs over extended periods. Lignin can be mixed with other polymers for 3D printing biomedical materials. Studies have shown that lignin composites provide good mechanical stability and biocompatibility. For example, incorporating lignin in polylactic acid improves printability and durability, which is useful for creating patient-specific implants. Due to its phenolic content, lignin demonstrates antioxidant and antimicrobial activities. It has been shown to be effective against pathogens such as E. coli and S. aureus. When used in films or coatings, lignin enhances the shelf life and safety of medical devices. Lignin nanoparticles can encapsulate and release drugs at controlled rates. Research has shown that lignin-based drug carriers improve the bioavailability and stability of drugs like curcumin and resveratrol. Lignin nanoparticles also exhibit UV blocking properties, which can protect bioactive compounds from degradation. The 3. We can conclude that fruit pomace lignin holds significant potential for sustainable biomedical applications, particularly as a component in hydrogels, 3D printed biomaterials, and drug delivery systems. Future research should focus on refining extraction processes and exploring more applications in biomedicine.